I'm just going to briefly introduce Christian, and then I'll start. So my name is Vijay Konkimala. Thank you for coming to the Mid-America IT Connect event. This is our 16th event, and we have had great speakers for the past couple of years in giving presentations in great technologies like data science, web analytics, connected cars, flying cars. We have a person who has given 2 presentations on connected cars. So if anybody wants to give presentations in the future months to come, you are most welcome, so please reach out to me, and I'll make arrangements so that we can host another event on AI, machine learning, and everything. So today we have Christian Brown. He's a subject matter expert in deep learning, machine learning, and AI, and he's going to talk about deep learning today.
We're talking about deep learning today, and in the past 5 years we could really see quantum leaps, what artificial intelligence, quote unquote, is able today, as opposed to what it was back, in the beginning of the 2000s, for example. You see better smart assistants, you see connected cars, autonomous driving, things like you never had imagined maybe 10 years ago that this really works. And many of these things are powered by one technique. This technique is deep learning. And I'll talk about a little bit what it is, where it comes from, a little bit the concept, and how it relates, maybe how our brain works. We'll avoid mathematical notation and stuff as much as possible. We will see a lot of illustrations and a live demo. And I'll try to keep that as simple as possible and as accessible as possible. And in the end, we will also do some digit recognition together. So let's see how that works out. And if you have any questions, please feel free to ask, or you can also ask in the after the presentation. So, and this is of course an eye chart. So I wanted to give you a brief history of artificial intelligence. And as you probably can't read that from that, I'll pass around the original here, so you can just have a look at it. Artificial intelligence and this picture, this a robot. This is something. It's fascinating, and it's fascinated people for a long time. So this is a picture of a robot from the 1939. So that was someone who envisioned how future robots could look like. So that was a topic for a very long time. And when in the 1940s the first real general purpose computers were developed, and of course for the military, people were thinking about what is intelligence and what is artificial intelligence. And we can go through the timeline in detail, but a few highlights only. Just, I don't want to bore you here. And I think the term artificial intelligence was coined in the 1950s. And that's pretty remarkable. So people were thinking about what is intelligence and how would you recognize that a machine is artificially intelligent, and what's the difference between not intelligent and intelligent. And back then people had high expectations. So expectations like we can achieve human-like intelligence within a couple of years. It was in the 1950s. We all know that really didn't happen. Our computers are super fast, they can calculate very fast, you can nowadays browse the web, but for many decades this expectation didn't come true, the expectations were not met. What basically started out in the 1950s and the 60s, people were researching what could artificial intelligence look like, and they looked at first at toy problems. How can I teach a machine or a computer to play chess. How can I teach a machine to play checkers? And well, there was some success in these kind of fields, but this was all really confined to these toy problems. It never really, there was never the jump from artificial research and into the real world problems, into, I don't know, applications for industries, for retail, or for other industries. And back then, all the expectations that were not met, that led to a so-called artificial intelligence winter, AI winter for short. So people were frustrated, disillusioned. It was not meeting their expectations, so they thought it's never going to happen. And some years later, we researchers then focused on a different topic, and that was expert systems. And they thought, okay, maybe we can teach machines the rules and something from experts. So maybe you have an expert in a retail environment, or an expert in different other industries, and how maybe we can pick their brains and extract what kind of knowledge they have and put that into machines. And they wanted to build these expert systems, but also these expert systems were not really successful. So in certain areas they were, but basically that led to another second AI winter. And I know that some people might see it a little bit different, but I just want to give you a little bit of context how I see it. So artificial intelligence is really a very broad term. It also connects robotics. It includes things that are machine vision and stuff. Machine learning is a much smaller topic, and machine learning is, and I'll come to that a little bit in more detail, is with machine learning, you want to teach your computers to learn out of some data, and you don't explicitly program to solve a problem. So you say, okay, here is data and here is how it should be. Learn the rules yourself. I don't explicitly program the rules. You have to find out the rules yourself. And deep learning is a subfield of machine learning. And what I just described is what's the difference between machine learning and classical programming. Basically, classical programming says, okay, I have data, I have rules, the programmer defines the rules, put it into a program, and then this program or this computer produces answers. In machine learning, you don't have rules, the people don't know the rules. You just give data, and you give sample data and known answers, and the machine is learning the rules itself. And then you can apply the rules for unknown data. So, first of all, we have improved algorithms, or the researchers have improved algorithms a lot, and we have much, much more data. So now we have tons of data in the World Wide Web. People are posting tons of things, labeled pictures. So this abundance of data can be used to train algorithms. And lastly, and I'll also explain that a little bit, democratization. Earlier, artificial intelligence was only for experts, but nowadays it's accessible for many more developers. You don't need to have the latest and greatest PhD and 20 years experience in the field. You can apply deep learning or machine learning without having this deep knowledge. Does anyone have an idea who sparked off a revolution in the AI hardware? NVIDIA. What did they do?
Many processing units in a single chip.
Yeah.
Hundreds of them.
And how did they start this? How did it start out? It was gaming.
Okay.
Gaming computers. Gaming computers made a change. Here, now, give you a picture. This is now a powerful workstation that uses GPUs. GPUs is graphical processing units, and NVIDIA was implementing is a producer of graphics adapters, and they have very powerful GPUs for vector graphics, so that you can smoothly see a lot of frames in your computer games. And then they figured out, well, we can use these GPUs not only for computer games, we can also use it for other things. In 2009, my company wanted to look into that as well and say, can we use GPUs also for our tools? So we are doing insights for the retailer, and I said, okay, we'll have a look at it. And I had a laptop with a powerful NVIDIA graphics adapter, and I said, okay, we'll implement that. But it's not as easy as it looked like. So it was a very low-level programming language. So you had to really use C++, and you had to explicitly write code for the standard computer, and you have to write code for your GPU. So you had two different paradigms, and you have to always think about, okay, you get data, but you have the data only in your main memory. You have to shift the data now into the graphics memory. Then you can process it, and then you have to shift the results back from your graphics memory to your main memory. It was, well, to say the least, complicated. What is deep learning? We didn't talk about that. And it's loosely inspired by how our brain works. But this is a biological neuron. I don't want to go into too much detail, but it's like you have a neuron that gets some input, and in certain circumstances, so the signals go in, signals go out, and this idea was, well, captured by so-called artificial neural networks and artificial neurons. I'm not saying that deep learning is exactly what happens in our brain. It's loosely inspired, but don't mix it up. So it's not just a copy of our brain. So artificial neurons, they look a little simpler, but they also get some input signals and they have output signals. It's very abstract. What does that really mean? Let's say we have a neuron that decides whether I go to the gym today. So the output is go to the gym, yes or no. And there are some factors that drive this decision. So maybe the three factors are maybe, have I had coffee or enough coffee? Was I in the gym yesterday? Yes or no? Do I have peer pressure? So these three are the inputs to the decision, do I go to the gym today? And these kind of inputs, they are not equal. So some are more important, some are not so important. So we'll put some weights to the inputs. So let's say coffee has a weight of 2, peer pressure has a weight of 6. What does it mean? Peer pressure is much more important. So if others go to the gym, even though I might not have coffee, I still want to go there. Probably to not look like a couch potato. And in this case, let's say, okay, these are the inputs, and whenever the inputs, and you sum the inputs up, whenever they exceed 4, it's the so-called bias, then I go to the gym. So when I got peer pressure, 6 is greater than 4, I go to the gym. If I had coffee and I haven't been to the gym yesterday, that's 2 plus 3, that's greater than 4, I go to the gym. If only this is true, so I only had coffee, but I was at the gym yesterday and there is no peer pressure. Coffee alone doesn't lead to the result that I go to the gym. So this is a little bit the idea. You get some inputs. The inputs are getting some weights, and whenever you exceed the bias, then you will have a signal output as true or otherwise as false. Things like image recognition. Does this look like a dog or not? That's a very important question. So classification of images. And I want to give you an example how that works with the deep learning network. So first thing is you set it up and you train it. That means you have tons of pictures and you give them labels. This is a picture of a dog, this is a picture of an elephant, this is a picture of a wolf. You put that through the network learns. We'll talk about how it learns a little bit later. And then, once it's trained, you can feed in images that you don't know. So, here's a picture. I don't know what it is. I put it through the network, and then it will give you the answer. So, the first step is, of course, in training. Once it's trained, it gives this an unlabeled image into the network, and the first layer basically responds to very simple shapes, like an edge, like, I don't know, some curves. So the first neuron responds to really simple things. The next level is already able to build things together a little bit. So you might be able to maybe, well, this could be maybe a tail, so respond to more complex things. And the more layers you have, the more complex things you can recognize. So simple things in the first layers, and it gets more and more complex and more powerful in the end. And then in the end, it will, in the output layer, will tell you that, okay, for example, there's a 90% probability that this picture is a dog, and maybe 10% wolf. And then you decide, okay, if 90% versus 10%, then we'll go with a dog, as opposed to wolf. So this is a little bit how image recognition works with deep learning. Very theoretical so far. I want to show you one playground. And let me try. I hope I can do that. And I hope that everything works with the resolution. So, a neural network playground. Okay, let me check. Okay, I'll have to read most of the things that you won't be able to read from the back. So this is a playground. This is an open source page. You can go there. You have the link. You can play around. You can say, I want to build up artificial neuron. Here's an input layer. Here are hidden layers, and there's an output layer. And what this network demonstrates is how, it demonstrates visually, how, for example, a classification problem, like is it a dog or is it something else, can be done with a deep learning network. And you can play around how complicated does the network have to be in order to do that. And what you do is you pick different data sets, and there are simple data sets and more complicated data sets, and then you can run it through, and the data set, so the training of that network is data points. And it's orange data points and blue data points. Now, will artificial intelligence take over the world?
According to Elon Musk, the answer is yes.
That was a pretty good segue. So it was good that we...
I never saw your slide, by the way.
Yeah. So, Elon Musk, and there was a conversation between Elon Musk and Zuckerberg. Elon Musk said something like, existential risk for human civilization. AI will take over basically the world. Zuckerberg said, well, that's irresponsible what you're saying. You are one of the naysayers and so on. And then I think Musk then retweeted and said, well, Zuckerberg's understanding of the subject is limited. So they kept fighting via tweets and so different people with different views. Bill Gates, in 2015 he was saying, I don't understand why some people are not concerned. So he was pretty critical then. In 2017 he said, well, it's not imminent, so we shouldn't panic. So also sometimes people change their viewpoint. And well, Stephen Hawking, November 2017. So AE could be the worst event in the history of civilization. This is just cut out one sentence. You also said it could be also one of the best. So, but it's okay. Maybe that's out of context, but I'll give you the context. He said also it could be one of the best moments. So pretty controversial. I think. Well, I don't want to predict. I think they speak for themselves. But I think there are some more imminent questions. And these imminent questions are: how does AI change our world now? Things like job market. And I think there will be a lot of changes. So there will be a search of, so there will be demand for AI experts. So if you are a graduate in the right field, I think you can earn a lot of money today. But what happens to unskilled workers that may be replaced by more, well, autonomous systems? And of course, if they succeed, you can imagine, then probably they will invest in these kind of things, and all the Uber drivers and all the Lyft drivers, they will probably not have not a second job anymore. So this is something that we probably have to keep an eye on. How will that change the job market? The second thing is bias and feedback loops. Networks or machine learning can be racist. And this is an example. I'm not sure whether you know that example. There's a camera, I think it's Nikon, so a camera vendor, and he has integrated something in their cameras, and whenever someone blinks, or so has its eyes closed, it will ask, did someone blink? Well, if you take a picture of an Asian person, the likelihood that it says, did someone blink, is much, much higher than for normal people. Well, if you don't feed the right data into it, it will be, well, is it racist? I don't know, but there will be bias. I want to close with further reading. Things, tutorials on the web, but there are also quite nice books. So for example, this book, I found that very helpful in learning how to use a specific library. So it's a lot of things that you can use, and you can use that. So this is Python for the programmers, and there are things for R, and so on and so forth.